Welcome to MACSGATE. Let us continue the DBMS classes. In DBMS, we are discussing normalization. Under normalization, in today's session, we are going to discuss about normal forms. So let us start the session. So in normal forms, first let me list out the normal forms which we are going to discuss or which we are having according to our GATE syllabus. So the first normal form we are having, sir, and the second normal form, and we are having third normal form. Then the next one is BCNF. In addition to these, we can also have fourth normal form. According to our GATE exam syllabus, these four are NF. First normal form, second normal form, 3NF and BCNF. Okay, first let me give overview of these normal forms. When coming to first normal form, it mainly deals with multi-valued attributes. Whenever there are multi-valued attributes, it will deal it. Similarly, if there are some composite attributes, so the first normal form deals with these two type of attributes. How to deal with these two types of attributes that we discussed, sir. When coming to the second one, the second normal form, it mainly deals with partial dependency. Partial dependency. What is partial dependency? How to handle it? That we discuss. When coming to the third normal form, it mainly deals with transitive dependency. Transitive dependency. When coming to BCNF, this is also same as third normal form, but he is a strict police officer. So the same transitive dependency we deal with in BCNF also, but it is very strict according to that particular rules that we see, sir. Okay, so let us continue these normal forms one by one. Before going to normal forms, I need to recall the definitions of prime attribute and non-prime attribute. We have discussed about these two in our earlier sessions. What is a prime attribute, sir? An attribute which is present in any one of the candidate keys. Attribute which is present in any one of the candidate keys is called prime attribute. Similarly, what is non-prime? Which is not prime, right? For example, suppose we have a relation R in which I have 5 attributes A, B, C, D, E, and let us assume I have 2 candidate keys. One is AC, the second one is B. Now the attribute which is present in any one of the candidate keys are prime attributes. So in this example, what are the prime attributes, sir? These are the prime attributes. What are the non-prime attributes? D, E. As we know, a relation can have so many number of candidate keys. Out of all the candidate keys, generally we select one of them as a primary key, right? So we need to know what is a candidate key and what is prime attribute, what is non-prime attribute to continue the discussion of normal forms. So let us start the normal forms. Coming to the first one, first normal form. What the first normal form says? A relation is in 1NF if the attributes are atomic. If the attributes are atomic, what does it mean? Sir, the attributes are indivisible. They cannot be divided further. So instead of this one, you can say multi-valued attributes are not allowed. Composite attributes are not allowed. We have already discussed what is a multi-valued attribute, what is a composite attribute. Again, let me recall those two definitions. What is multi-valued attribute? An attribute which is having so many number of possible values. For simple example, suppose mobile number is the attribute. A person can have more than one mobile number, right? Suppose I am considering age attribute. Every person will have only one age. He cannot have more than one age. Okay. So phone number is multi-valued attribute. Similarly, suppose I consider mail ID. A candidate can have more than one mail ID. So that is the example of multi-valued attribute. Then what is composite attribute? Composite attribute means the attribute can be divided further. For simple example, name. Whenever I consider a name, I can divide the name into first name, last name, surname. This is the simple example for composite attribute. So these two type of attributes are not allowed when we are considering first normal form. Right, sir? Suppose if I are trying to create a relation with these two type of attributes, the DBMS will not accept. That means those tables will not be created. Right? So then how to handle it? For composite attributes, suppose I have a relation student. Let us assume the relation name is student, whose attributes are student ID, name, age. Actually, here the name further divided into two attributes, first name, last name. We don't have any provision to create composite attributes in DBMS. Then what should we do? We need to separate these sub attributes as independent attributes. That means I need to create like this. I need to create the same student table with student ID, first name, last name. If you observe here, these two are two independent or individual attributes. They don't have any connection. Clear, sir? So that is how to deal with composite attributes. So I should not write any attribute like this. That is the first one. Clear, sir? Then how to deal with multi-valued attributes. For example, suppose I am having the table student in which we have attributes student ID, name, age, subjects. Okay. When coming to student ID, name, age, they are very clear, sir, and they are atomic. Let's come to the attribute subjects. Actually, here my intention is what are the subjects the student is enrolled in the course, right? So let us suppose the student 11 or Lakshmi registered two courses, DBMS data structures. Similarly, Sudhakar registered operating systems. And let us assume the student Raju has registered computer networks and DBMS. So this is an example of a multi-valued attribute because that attribute is having multi-values. Multi-values means what, sir? It is having more than one value. It is having more than one value. Then these type of multi-valued attributes are not allowed according to first normal form. Then how to deal it? To deal with multi-valued attributes, there are so many possibilities, sir. Let me discuss each of possibilities one by one. The first possibility, what I do is the student 11 has registered two courses. So I write the entire record for two times. I write the entire record for two times. For first time, I will write the first value. For second time, I will write the second value. Right? Similarly, the student Sudhakar registered only one subject. So I write the record for only one time. When coming to 33, Raju, he registered two courses. So I will write the record of Raju for two times. Right? Then what are the key points we need to keep in mind? The first problem is, suppose a student Lakshmi has registered 10 courses. Let us assume the student Lakshmi has registered 10 courses. Then in that particular situation, what we supposed to do, sir? I need to store the details of Lakshmi for 10 times. For 10 times. So it leads to redundancy. We are storing the same data for 10 times. Okay. So which is wastage of memory or which is redundancy. Hope you understood it. So that is the main drawback of this possibility, right? So let me discuss the second one. The second possibility, sir. Here we, that is the creator of the database, will decide what is the maximum number of subjects the student can register. So in this example, what happens is, I am deciding the student can register maximum of 2 subjects. So I return 2 columns, subject 1, subject 2, right? Suppose I feel that a student can register maximum of 3 courses, then I will add one more column, subject 3, right? So this is the second possibility. Here we don't have any multi-valued attributes. Now what are the problems? Sir, the first problem, suppose out of 100 students, let us assume we have 100 students. Let us assume we have 100 students. Assume only 2 or 3 students registered 2 subjects. Assume only we have 2 students who registered 2 subjects. All the remaining 98 students have registered only 1 subject. Then what will happen, sir? We will get null value. We will get null value for all those 98 students. So that means we will get more null values. This is the first problem, more null values. What is the second problem? Here we have given only 2 columns, subject 1 and subject 2. Suppose a student want to register third subject and fourth subject also. Then where to store the details, sir? We don't have any provision to store all the details of the subjects which the student registered. So unintentionally or unknowingly we are making a restriction on the number of courses the student is going to register, right, sir? Then in such case you may feel that, sir, why don't we put subject 1, subject 2, subject 3, subject 4, subject 10? Then what will happen, sir? We will get more number of null values. Hope you understood it. So this is the second possibility. So that's why most probably people don't consider the first 2 possibilities, sir. Of course we can consider it, but generally people will prefer the third possibility. What is the third possibility? What is the multi-valued attributes, sir? Subjects. So delete it from the original table, right? For this, or to follow the third possibility, I need to know what is the primary key of the table. Let us assume student ID is the primary key. Student ID is the primary key, right? So the first step is I need to delete the multi-valued attribute from the original table. If I delete it, what else we are having, sir? Student ID, name, age. So these are the attributes of the original table after deletion of the multi-valued attribute. Separate or form a new table. Form a new table with the multi-valued attribute and attach this primary key as a foreign key in the new table. So here this is the primary key. And that primary key we attach here in the second table as a foreign key. Right? So this is the third possibility which generally people will prefer. So we create tables SID, name, age. So this is our original table or the parent table. In which the first attribute is SID. And we created this one as a child table. Okay. And this is our foreign key. Clear, sir? Now for child table, the first point is, what is the primary key for child table? That is SID, comma, subjects. The combination of these two will be a primary key. And one more is, suppose the student 11 registered for 2 subjects, then I write 11 for 2 times. Okay, then it seems to be almost same as the first possibility. Then what is the advantage of it? Sir, please observe it. In child table, we are repeating student ID for 2 times, not all the attributes of the student. Suppose in the main table, we are having 100 attributes for every student. If I follow the first possibility, I need to repeat all the 100 attributes for 2 times. So, which will give 200 duplicate entries, right? But here we are repeating only the student ID for 2 times. Hope you understood it. So, this is the step we need to follow for first normal form. When we have created a table in DBMS, by default it will be in first normal form, because if you don't follow the rules of first normal form, it is not allowed us to create the table. So that means when you create a table, it means that it is already in table. So if you assume the table has created, it means that it is in first normal form. If you are trying to violate first normal form, it will raise a error. You cannot create a table like this. Hope you understood it. So by default, whether they give records or not, whether they give any information or not, if says the table was created in database, that means it is in first normal form, right? Let us go to the second normal form. Okay, the second normal form mainly deals with partial dependency. A relation is in second normal form if, first of all, it should be in first normal form. Of course, by default, it will be in first normal form. What is the second one? All non-prime attributes are fully functionally dependent on key. Fully functionally dependent on key. The same thing you can write in another way. No partial dependency. Let me explain the meaning of the second point. Whenever I consider a non-prime attribute, it should dependent on the key completely. It should not dependent on the key partially. What is the meaning of completely? What is the meaning of partially? Let me explain with an example. Suppose we are having a table in which we are storing the details of employee projects. Okay. Let us assume EID is the employee ID. PID is the project ID. Hours, the number of hours the employee worked on so and so project. Employee name, project location. Okay, let us assume for this table the primary key is employee ID combination of project ID, because suppose an employee 11 may work on project 101 for 10 hours. The same employee may work on project 104 for 15 hours. The same employee may work on another project for 5 hours. Similarly, on the same project, I can have one more employee who can work for 20 hours. Okay. 22 may work on this one also. So that means whenever I know only the employee ID, I cannot identify the record uniquely. Sir, this is our assumption only. Okay. An employee will work on so many projects. On the same project, so many employees will work. So these are the two assumptions we are having, sir. In such case, compulsorily, I need to know employee ID and project ID. So this is the primary key for the table. This is our assumption, sir. Hope you understood it. Now, since it is a primary key, I can write employee ID, comma, project ID will imply the number of hours because it's a primary key. So it can imply any other attribute. Employee ID, project ID. By the property of primary key, it will imply e-name also. Employee ID, project ID will imply project name also. Similarly, project location, right? So this is the assumption about this particular employee. Now please observe the first dependency. If I want to find the number of hours, if I want to find the number of hours, if I know only employee ID, can you get it, sir? No. If I know only 11, I cannot identify the number of hours because the 11 employee may work on different projects. Without knowing the project number, I cannot give the number of hours he contributed to that particular project. Similarly, suppose I given only project ID. Can you give the hours of the particular record? No, sir. For the same project ID, I may have multiple number of records in which so many employees has worked. So to find the number of hours, compulsorily I need to know these two values. That means hours is completely dependent on these two. Completely dependent on these two. Now let's come to the second one, employee name. To find employee name, does we need both attributes, employee ID and project ID? Is it mandatory, sir? No. If you use our simple common sense, to know the employee name, why should I know the project ID, sir? Right? So it's not needed. That means this employee name is dependent on only employee ID, not on project ID. So it is an example of a partial dependency. Hope you understood it. It is an example of a partial dependency. Right? Similarly, what about project name? To find the project name, why should I know the employee ID, sir? To find the project name, it is enough to know the project ID. So this is also one more example of partial dependency. Even project location. Where is the project location? To find the project location, I need to know only project ID, not the employee IDs, right? So these are the examples of partial dependencies. According to second normal form, we should not have any partial dependencies in our relation. Now the question is, suppose we have partial dependencies like in this example, what should we do? Sir, for every normal form, the ultimate solution is decomposition. So that's why we have learned the properties of decomposition in our earlier sessions, right? So the solution is decomposition, that is sure. Now the question is how to decompose, that is what are the attributes in the original table, what are the attributes in the child table, that we need to identify. That is the responsibility of the second normal form, right? So let me explain how we will decompose this relation according to second normal form, and if I assume these assumptions. Hope you understood it. So let us continue the decomposition possibility of this example. So this is the table we are having, sir. Now the first partial dependency, what is the first partial dependency you are having, sir? Employee name. This is an example of a partial dependency. Here, who is the villain, sir? Or who is the culprit? This is the culprit. So delete it from the original table. Delete it from the original table. Write the remaining in the original. So we deleted it, and because of this employee ID, he became villain. So this is my child table. Hope you understood it. Sir, who is villain? That we are completely deleting. Who is responsible? That we are adding as a foreign key. Then what are the remaining attributes in the original table, sir? These are the attributes. Please observe 2 points. Whoever culprit, that we are completely deleting. Who is responsible, that we are adding as a foreign key. We are not deleting from the original table. Please observe it, right? So this is the first story. So we eliminated this functional dependency. Now in this table, this will be the primary key. Because whenever I know employee ID, I can find employee name. That's it. And anyway, this we bought from the original table. So this is an example of a foreign key, because that we got from the original table. Hope it is clear, sir. Now here in this table, the primary key is only one, and I have employee ID implies employee name. Now the question is this attribute fully dependent on this or completely dependent on this? Yes, of course. Sir, I have only one attribute. So it is mandatory to find employee name. In the previous case, I have two attributes. So I may have a thought of removing one attribute. Suppose I have two employees in my department. Now I may have a thought of, if I remove the first employee, can the work will be continued? So I will think whether I am depending fully on those two employees or one is extra. Can I remove it? Suppose I have only one employee in my department. Do you have any thought of removing him, sir? No. Right? So whenever the dependency is having only one attribute on the left side, surely it will be fully dependent. There is no chance or no concept of partial dependency. What else you are having, sir? You are having two more. What are the two more dependencies? That is project ID implies project name. I have one more. Project ID implies project location. So now I have two villains, project name, project location. Delete them from those two. So delete them from the original table. And who is responsible, sir? Project ID. So create a new table with the project name, project location, and add this primary ID to the table. So this is the table which we already created, sir. What is the new table we are going to form? Project name, project location. These two are villains, sir, and these two became villains because of only one person. So we can have it in a single table, right? Then what else you are having? Employee ID, project ID, hours. Hope you understood it. So in this example, this is the primary key for this table. So the primary key for second table is project ID. Whenever you are having this one, we'll have only project ID implies project name. The left side I have only one attribute. So there is no concept of partial dependency. Hope you understood it. Similarly, we have already given, sir, what is the primary key for these? That is employee ID. Anyway, these two are foreign keys. These two are foreign keys, which we borrowed them from the main table. Hope you understood it. So this is the way how to decompose the second normal form. Now, in this example, we made some assumptions about attributes. What is employee ID, what is project ID, what are the hours and everything, sir. Okay. Now, suppose if they given a relation without having any attributes, I mean without having any details of the attributes, how to decompose that second normal form or everything. Okay. That we discuss in this session. Right. So let us consider this example. Here I don't have anything, sir. In the previous example, it is a real-time example or in which we have some domain knowledge. Now in this example, I don't know anything. Then how to do it, sir? Sir, the first thing is I need to know the functional dependencies. They given functional dependencies. Fine. The second thing is I need to know the primary key and all the candidate keys. Then only I can do it. Okay. Now in this example, please observe it. How to find the candidate keys, sir? In our earlier sessions, we have already discussed how to find the candidate keys for a given relation with a given set of functional dependencies. Let us continue it. On the right side, I have D, on the right side, I have C, but I don't have A, B. That means compulsorily AB must be present in my candidate key. Let me try whether this is a candidate key or not. Sir, if this becomes a candidate key, I have only one candidate key. Otherwise, I need to find all the possible candidate keys. Now, what is the closure of AB, sir? With the A, I can get A. With the B, I can get B. Anything else? I have a functional dependency. A implies D. So, I can have D. We have a functional dependency. AB implies C. So, I can get this one. So, we got all attributes. We got all attributes. So what is the candidate key, sir? For this example, the candidate key is AB. Sir, suppose if the candidate key contains only one attribute, there is no concept of partial dependency. That means no need to verify anything. It will be in second normal form, because whenever I have only one employee or one attribute in candidate key, I am fully dependent on him. There is no chance of partial dependency, right? So in this example, the relation R is A, B, C, D. This is my candidate key, one and only candidate key. So let us assume it is our primary key. What are the functional dependencies? A implies D. This is the first functional dependency, right? Here observe it. Either this should be prime attribute. If this is a prime attribute, I will leave it. That means I can skip it. If it is not a prime attribute, compulsorily I need to consider it. So what is the left side, sir? It is a part of the primary key. That means D is not fully dependent on AB. Actually, D should dependent on AB like this. But it is not completely depending on AB. So it is depending on only A. What I need to do, sir? Delete it. Form a new table. Who is responsible for villainism of D, sir? A. So this is my child table. Then what else you are having in the parent table, sir? A, B, C. Any other dependencies? I have one more functional dependency. What is that, sir? AB implies C. If you observe it, to find C, I need both of them, AB. Hope you understood it. So it is not an example of a partial dependency. Hope you understood it, sir. So this is the way how we will decompose the relation to satisfy second normal form, right? Let us do one more example. Let us consider it, sir. The first step is how to find the candidate key. How to find the candidate key? Sir, please observe it. D, E is present, C is present, but AB is not present. So what is AB closure? If you are getting any doubts, please raise in chat box. What is AB closure, sir? With A, I can get A. With B, I can get B. With A, I can get D, comma E. With AB, you can get C, right? So we are getting all attributes. So the example is a candidate key. AB is the one and only candidate key. Since AB is the one and only candidate key, we will designate it as a primary key. Now the relation is, what is the relation, sir? I have 5 attributes: A, B, C, D, E. If you consider the first functional dependency, A implies D, E. Sir, please observe it. These two are the villains. They are not completely depending on AB. They are depending only on A. So that is an example of a partial dependency. Because they are depending on only A, not on B. So what I need to do, sir? Remove these two villains from the original table. I removed it. So let us make a new table with D, E. Who is responsible for this villainism, sir? The responsible person is A. So this is our child table. After deletion of D, comma E, what else you are having in the main table? I have A, B, C. So this is my parent table. Hope you understood it. So those who are villains, that we remove them from the original table. Who are responsible, that we add as a primary key, right? I mean, we are bringing from the original, so it becomes a foreign key and it will be the primary key in the child table, right? Let us go to one more example. Suppose I have a relation with the same 5 attributes, sir. A implies D, B implies E, AB implies C. Okay, Then I have D is present, E is present, C is present. I don't have AB, sir. So let us find the closure. I can get AB. Then with the A, I can get D. With the B, I can get E. With the AB, I can get C. So that is an example of a candidate key. Right? What is the table you are having, sir? The original table is R, in which I have 5 attributes. Let us consider the first FD. What is the first FD, sir? A implies D. Because of this, D becomes villain. So remove him. Who is responsible, sir? A. Then what else you are having in the original table? A, B, C, E. Right. What is the second FD, sir? B implies E. Still, we are having a partial dependency in this example. He is the villain. So remove him. Who is responsible? B. Then what else you are having? You are having A, B, C. Already I have A, D. Right? What about third functional dependency, sir? AB implies C. So C is completely depending on both A comma B. There is no problem with functional dependency. Hope you understood it. So this is about the second normal form, sir. Now let me give some small note about second normal form. Any relation in which every key is a simple key. Sir, what is simple key? It has only one attribute. I already explained about this, sir. If in my team I have only one employee, I am completely depending on his employee, on that employee. Suppose if I am having 2 members or 3 members, then there is a chance that I am partially depending on one employee and the other 2 employees may not working well, right? So when I have only one attribute, there is no concept of partial dependency. By default, it will be in second normal form. Hope you understood it. Now let's go to third normal form. Sir, third normal form or BCNF, both are same. But third normal form is something like a government employee who is liberal. Okay? Who is liberal? That means he can skip some of the VIPs or some of the MLAs or some of the political leaders. But when coming to BCNF, it's not like that. Whatever him, he will be very strict. He will follow the rules for each and every person. Hope you understood it. So third normal form and BCNF both are same employees will do same work. But when coming to third normal form, he is a liberal or he is a good hero. He will skip some of the persons depending on the situation. But when coming to BCNF, he is very strict. He don't consider any situations or any possibilities. Then what is the duty of employee? First of all, a relation is in third normal form. If it should be in second normal form, we already explained what is second normal form, sir. Then the second condition, for any non-trivial functional dependency, whenever I have a x goes to y, then either x must be a super key. That means LHS always a super key, sir. LHS always a super key. This is the primary responsibility of both normal forms. So they need to verify for every FD, we are having a super key on LHS. But when coming to third normal form, he is a liberal. That means he will give some considerations. Even LHS is not a super key. He will skip some of the persons. What are those persons? Or the right side is a prime attribute. That means suppose I am having x goes to y. If this is a super key, there is no issue at all, sir. There is no issue at all. Suppose I have a functional dependency A goes to B. Now this is not a super key. Whenever this is not a super key, there is a issue. When coming to third normal form, even whenever there is a issue, he will observe the situation clearly. Whether the right side candidate is an important person or not. If he is an important person, then he will say, yes, chod the boss, let us leave him. Right? So that means he will skip or he will give some consideration for this functional dependency. But when coming to BCNF, he don't consider any considerations. Whatever the right side may be, he don't consider. No excuses. That's it. Okay. First, before going to that one, first let me explain with a real-time example. Suppose this is the example we are having in which we have some knowledge about attributes. Aadhaar, that is Aadhaar number of the candidate, state in which he belongs to, voter ID, name, city, postal code. Okay. Now let me give some assumptions, sir. In this we are assuming some assumptions. When coming to candidate keys, by default are the property of Aadhaar number. By using Aadhaar number, we can identify any candidate in India uniquely. That means by using Aadhaar number, we can identify the persons uniquely. Right? Now let us assume one more. Sir, I am not sure about this, but I am assuming it. Let us assume the voter number is unique within the state. I don't know whether it is unique across the India, sir, but let us assume within a state, that is in Andhra Pradesh, the voter number is unique. In Tamil Nadu, the voter number is unique. That means let us assume the voter number is 22. Whenever I consider the people in Andhra Pradesh, there will be no other voter whose voter ID is 22. But if I go to Tamil Nadu, there is a chance of having voter with 22. I don't know it, right? We are assuming it. So whenever I know state, voter ID, so I know the voter number is 22 and the state is Andhra Pradesh. Then I can identify the person very clearly. Similarly, suppose I have a voter ID 22 in Tamil Nadu also. Then if I know the Tamil Nadu state name, I can identify it. So these are the two assumptions. This is my candidate keys. One of these will be designated as a primary key. Anyway, now to discuss this normal form, third normal form, we don't need about any primary key. We need to know what are the possible candidate keys. Fine. And one more, sir. Please observe it. Third normal form will give importance or will give excuses for prime attributes. That means considerations. So to give considerations, I need to know the prime attributes. In this example, with these assumptions, what are the prime attributes? Aadhaar, state, voter ID. What does it mean, sir? Whenever I have a functional dependency like this, first it verifies whether it is a super key or not. If it is a super key, we don't have any issue, no need of any excuses. Suppose it is not a super key, then it verifies the right side. If it is any one of these three, then he will excuse. So that is according to third normal form. So let us consider. Then suppose the left side is not a super key, the right side is not a prime attribute, he is not important. So both conditions failed. He is not satisfying condition and he is not important. Then what is the punishment? Punishment is always decomposition, sir. How to decompose? That is the main story. Let us consider it. So in this example, let's consider it, sir. So Aadhaar, state, voter ID, city, postal code. If you observe here, whenever I know the postal code, I can find city. Am I right, sir? Because the postal code is unique across the India. So whenever you know 523007, you can identify the corresponding city is Vijayawada. Like that, by using postal code, you can identify city. Now the question is the left side is a super key? No, sir. We have only two candidate keys. One is Aadhaar number, the second one is state voter ID. So the left one is not a super key. So he is not satisfying the conditions. Then whether the right side is important to you, verify it. City, he is not a prime attribute. So that means he is not following the rules and he is not a VIP like MP or MLA. Then punishment, that's it. What is the punishment? City is the punishable or victim. So delete it from the original table. Who is responsible, sir? Postal code. So city, postal code. That's it. What else you are having, sir? You are having the remaining Aadhaar, state, voter ID, name, postal code. Hope you understood it. Now, if you observe very clearly, in this we have one more also. Suppose whenever I know postal code, sir, by looking at the postal code, I can identify the corresponding state also. Across the India, postal code is unique for each and every city as well as it is unique for state. Oh, by knowing or whenever I know postal code, I can identify the corresponding state also. So this is also one functional dependency. If you observe very clearly, what about the right side? Is it a super key, sir? No. It is not a super key. That means he is not following the rules. Now, whenever he is not following the rules, we observe whether the right side person is a important person to us or not. Because we are not strict police officer. We are very liberal police officer. The right side is state. Sir, state is a prime attribute. Whenever he is a prime attribute, something like a VIP. Okay, fine, sir. Please go on. Please carry on. Okay. No need to follow any rules because you are VIP. Right. So whenever the right side is a prime attribute, he is a VIP, sir. VIPs don't follow any rules. No need to follow. Of course, they may follow, but no need to follow. We will excuse it. So that's why we don't consider this or we don't do any decomposition with respect to this dependency. Hope you understood it. So again, I'm repeating, sir. Whenever I have a functional dependency, compulsorily the left must be a super key. That is the rule. That's it. If it is not a super key, it should be punishable. But 3NF will give excuses for prime attributes. 3NF will give excuses for prime attributes. Hope you understood it. So the same concept we are going to discuss for BCNF also, sir. For BCNF, no excuse. The left must be a super key. Otherwise, decompose it. That's it. Hope you understood it. So let me complete that BCNF. So before going to that BCNF, let us consider one small example in which we don't have any domain knowledge. So here we have a relation with 5 attributes. AC implies D, B implies E, D implies C, A implies B, A implies C. D is present, E is present, C is present, B is present. I think A is not present, sir. So let us find the closure. Sir, we are finding the candidate key. To find the candidate key, identify the attributes which are not on right side of any functional dependency. How to identify candidate keys that we have discussed in our earlier sessions. Please go through those sessions if you have not attended that class. Then with A, I can get A. Anything else possible, sir? With A, I can get B. With A, I can get C. Whenever I have AC, I can get D. Whenever I have B, I can have E. So that means A is a candidate key. So this is the one and only candidate key. Is the only candidate key. Hope you understood it, sir. Right? Now, consider the relation A, B, C, D, E. Right, sir? What is the first functional dependency, sir? AC implies D. AC implies D. The left is a super key because I have candidate key on left side. So it is following the rules. What about second one? B implies E. Is it following the rules, sir? No. The left is not a super key. So he should be punishable. But before going to punish him, please verify whether he is a relative or he is important to us. He is not important. Okay. So remove him. Whenever we remove, what will happen, sir? E. Who is responsible? B. What else you are having? A, B, C, D. What is the third functional dependency, sir? D goes to C. Is the left side is a super key, sir? No. He is not following rules. Is the right side is important? No. So remove him. Sir, anyway, the villain will be removed. Who is responsible? He will be added as a foreign key. So C will be removed. Who is responsible? D. Then the remaining is A, B, D. The next one is B, E. What about the remaining two functional dependencies? A implies B. The left is a super key. He is following rules. What about the next one? A implies C. He is also following the rules. Fine. So whenever any candidate is not following the rule, what is rule, sir? Left must be a super key. If he is not following a rule, observe the right side. If he feels he is important to you, important in the sense primary attribute. Whenever it is a primary attribute, please give excuse. No need to decompose. Suppose he is not following rule and he is not important to us, then we decompose. Hope you understood it. Right? So let us consider one more, sir. I think the same example we are having. I think, is it so? I think not, sir. Yes. So same, sir. D is present, E is present, C is present, B is present, C is present. Again, I have A. What is the closure of A? With A, I can get A. With A, you can get B. With A, I can get C. With AC, I can get D. With B, you can get E. So we got all attributes. So this is a candidate key. Right? So what is the relation, sir? We are having A, B, C, D, E. What is the first functional dependency, sir? AC implies D. It is following the rules because the left is a super key. What about the second one? B, E. Is it following the rules, sir? No. Is the right side important? No, it's not a primary attribute. So decompose it. So when you decompose, E should be deleted. Who is responsible? B. Then what else you are having? A, B, C, D. What is the third functional dependency, sir? B implies C. The left is not a super key, not following rules. The right is not a important person. So remove it. C, who is responsible? BC. Now, what else you are having? A, B, D. Already we have B, comma, E. Now, please observe, for these two tables, C, comma, E are villains and B is the common person who is responsible for these two. So, in such case, we combine those two into single table because it is the only primary key for both tables, or he is the responsible person for those villainisms. Right? What about functional dependency 4? A implies B. He is following rules. What about functional dependency 5? A implies C. He is following rules, right? So this is the decomposition according to third normal form. Hope you understood it. So let us consider one more. D is present, sir. B is present. D already verified. C is present. E is present. BC is present. BC already verified, sir. I think A is not present on right side of any attribute. What is the closure of A, sir? A, okay. With A you can get B. With A you can get D. Of course, with A you are getting all the values, right? Right? Then you are getting C, comma, E, everything, sir. So again, this is the candidate key. Sir, a relation can have more than one candidate key also, sir. Those examples we discuss in next session. The main agenda of this session is to introduce normal forms. We discuss more number of problems in next session. Now, this is the story, sir. Please observe it. What is the first functional dependency? BC implies D. BC implies D. Is the left side is a super key, sir? No. It's not a super key. Am I right? Yeah, it's not a super key, sir. Is the right side important? No, sir. So, who is the culprit? D. Remove it. Who is responsible? Sir, now two responsible persons are there. Attach them as a foreign key. What else you are having? A, B, C, E. Fine. What is the second functional dependency, sir? A implies B. It's fine because the left is a super key. What about third functional dependency? A implies D. The left is a super key. It's fine. What about fourth functional dependency? A implies C. The left is a super key. It's fine. What about next one, sir? Fifth functional dependency. A implies E. It is also fine. What about sixth one? D implies B. Sir, please observe it. From the second table. Okay, let me write the tables here. A, B, C. B, C, D. Right, sir? Now we are having like this, sir. According to, as we said, these two we borrowed from the original table. So, for this table, the primary key is BC. For this, we already calculated the primary key, which is A. Now, in this, we are having D implies B. Is the left side is a hero? No, he is not a super key. But if you observe clearly, the right side is a prime attribute. So you can skip it. Similarly, what about seventh functional dependency, sir? D implies C. The same story. Even the left is not a super key, the right is a prime attribute. Clear, sir? So this is about the third normal form decompositions. Hope you understood it. Now let's go to Bowie code normal form or BCNF. Sir, the same example, the same story. Whenever verify whether each and every functional dependency is following rules. If everyone is following rules, no issue. If they are not following rule, what is rules are? The left is a super key. If he is not following a rule, 3NF will look at who is the person who violated the rule, because you want to consider them whenever they are important. BCNF don't consider anything. So he will concentrate only whether they are following the rule or not. So he will concentrate only on LHS. He don't consider or he don't look at the right side. So it is in BCNF. If it should be in second normal form, and for every non-trivial functional dependency, we need to focus only on the rules, not on the important or not important. X must be a super key. That's it. So let us consider the same example. This one. I already explained the assumptions about this, sir. Aadhaar is one candidate key. State, voter ID is one candidate key. So these three are the important persons, right? Now let us continue how to decompose with respect to BCNF. Whatever the duties 3NF do, the same will be carried out by BCNF also. But BCNF will punish some of the important persons also. Okay. For this example, what we have considered, sir, the first one, postal code implies city. Sir, the left is not a super key, the right is not an important person. Anyway, BCNF don't consider the right side. So no need to look about the right side. That's it. So he will decompose city, delete it. And responsible person is postal code. What else you are having, sir? This is what you are having. What else you are having? We are having one more, which is postal code implies state. In this functional dependency also, the left is not a super key. So don't tolerate, delete it. Remove state, that's it. Right? So postal code city already we have, sir. Postal code state. So state we are removing, and responsible person is postal code. What else you are having? This one. Now please observe these two tables. For these two tables, what are the primary keys? Postal code implies state, postal code implies city. So we need to combine these two tables into a single table. Postal code, state, city. Hope you understood it. So BCNF, 3NF both are same employees. 3NF is liberal, BCNF is strict. That's it. So let me give some notes about normal forms. Sir, 3NF, BCNF decompositions always ensures lossless. What does that mean? If we decompose according to 3NF or BCNF, always the decomposition will satisfy lossless property. Then coming to the second point, 3NF always ensures dependency preserving, but BCNF may or may not. Whenever I decompose the relation according to 3NF, surely it will satisfy dependency preserving also. That means with 3NF decomposition, I will have lossless as well as dependency preserving. So no need to verify these two properties. Whenever you decompose with respect to 3NF, the decomposition will always satisfy these two properties. But whenever you decompose with BCNF, lossless is guaranteed, sir. Dependency preserving may or may not. Sometimes it may satisfy, sometimes it may not satisfy. That means I need to verify it. So dependency preserving, I need to verify it because it may or may not. That's the meaning of these two notes, sir. Let us give some more notes. Sir, we are having fourth normal form, fifth normal form, and sixth normal form also. But according to our GATE syllabus or GATE exam point of view, no need of discussion of these three normal forms. So that's why we are not discussing these normal forms. Okay. And one more point is, whenever we are creating a database in real time, no need to consider up to BCNF. 3NF is enough. So that means in real time, when you create a database, 3NF is advocate. That means if you decompose the relations up to 3NF, that is enough. No need to go for BCNF. If you want, you can go, sir, but it's not mandatory. And one more, this already given, sir. Sorry, this I have not given. For any relation with two attributes, whenever I have a relation with two attributes, it will be in sixth normal form. That means It will satisfy first normal form, it will satisfy second normal form, third, BCNF, 4, 5, all normal forms. Whenever it is having only two attributes, right? The next note is BCNF gives 0% redundancy. So that means whenever we decompose the relation with respect to BCNF, it will give 0% redundancy. There is no chance of redundancy. So these are the some theoretical important points about normal forms are. Okay. Of course, we can discuss all these points with some suitable examples. Because of the time constraints, I have listed all the important points here. Hope you understood it. So this is about normal forms. In next session, we will discuss some of the previous questions and some important examples on normal forms. Thank you.